planet Earth, or looking at this angle, maybe it should be called planet water, really, because 70% or even more than 70% is covered by water. So 50 years ago, 3 explorers went to the moon and came back. And of course, a big achievement. And 9 years before, 2 explorers went to the deepest point of the ocean. So the Apollo astronauts actually now put more people on the moon than people on the deepest point of the ocean. And up to now, that's still true. So 3 times more people have been on the moon than at the bottom of the Mariana Trench. Only 4 people have gone there so far. So why is that? So, I mean, this is a lot of ocean to explore. A lot of places we don't know very little about. We know roughly how deep it is, but we don't know what the exact temperatures are. We don't know the pH levels. We don't know the CO2 levels, oxygen levels, fish populations. It's just such a vast space. And it's very difficult to get covering information about all of it. And it's really important that we understand the oceans because they're such a big part of our climate, our economy, our life support system on Earth. So why is this so difficult? So like space, water is underwater. The deep sea is a very, very hostile environment for people. There's no air to breathe. Once you go down deep, the pressures are incredible. At the deepest spot, at 11 kilometers, every square centimeter has 1 ton pushing down on you. So imagine putting a car on your fingernail. That's how much pressure there is. And so it's very difficult for people to go there. But that shouldn't really stop us. I mean, we're clever people. We can invent technology. We can overcome these challenges. I mean, even Leonardo already thought about underwater breathing apparatus, like this diving mask, and he had thoughts about submarines, which he didn't really want to share because he saw the big potential for this to be abused. So there, this technology can be built. So we can have people go to the bottom of the ocean. For example, we have these submarines here. These are 2 Russian Mir submarines, which are rated to 6,000 meter depth, so they can go almost anywhere to the bottom. There are only a couple of submarines in the world that can go that deep. These are actually the 2 submarines that James Cameron hired to go to see the Titanic for his movie. And a few years ago, the co-founder of Hydromea, Alexander Barr, my colleague, and me were lucky enough to actually dive in those incredible machines and go down to the bottom of Lake Geneva, which is not so deep, but it was very exciting. Well, very exciting, but as you can maybe see, so on the outside, they look very big, but the pressure sphere is only 2 meters in diameter, so there's barely enough space for 3 people. It's very cramped. The air gets stale. You have to very carefully monitor the CO2 and the oxygen. So after 6 hours, we were actually quite happy to get out again and stretch our legs and breathe some fresh air. So yes, we do have these machines to basically go anywhere we want in the ocean, but it is a very time-consuming, very uncomfortable, very expensive way to go exploring, and we cannot really cover all of it doing that. It's just not scalable. So now, on land, every square meter of the planet has been mapped. You can pull out your phone, you can get satellite images wherever you are. GPS will tell you within centimeters where you are on the planet. This has become very normal. With using satellites, we can get hyperspectral images that tell us if there's parasites affecting a forest, how the crops are doing on a field, if there's pollution, where it is coming from, if there are forest fires. We can see all that from space using cameras, using radar, using X-rays. We can map every mountain. But for the oceans, all we see is the surface. We don't have these incredible maps for the subsea environment. We cannot see where the fish are. We cannot see where the pollution is. We can see some of the plastic that floats on the top. We cannot see the plastic at the bottom. So why is that? And why is this so difficult? Why don't we have that already? So now you might think that water is really clear, but in fact, it's actually opaque to almost all of electromagnetic radiation. All the technology that we know, like Wi-Fi, GPS, radar, the terahertz scanners that you see at the airport for the security checks, and even X-rays, they all get absorbed very, very quickly, and they penetrate maybe a few meters or maybe even only millimeters through the water. And the only exception is very, very low frequency radio, which is very limiting because you can't transmit much data, you can't do very much with that. and a very narrow window in the visible range of light. For blue and green light, you can go maybe 10, maybe 100 meters through water. But other than that, it's basically all dark. We can't really see anything. So that means if you put a satellite in space and we look down, we see the surface, we can maybe get the temperature of the surface, but we cannot look down into the deep. We cannot do measurements for CO2, pH, and so on from satellites. So remote sensing, as it's called, would be a very powerful tool, but it's not really possible to use that to do exploration at scale in the ocean. So now for underwater exploration and mapping, typically people use acoustic waves, sonar, which does allow us to get the depth. We can make maps, but it's also very limiting. It's very difficult technology. Sound travels for many kilometers, but we can only transmit very little information with acoustics. And so that's also challenging, possible, but again, we cannot do it from space. We cannot just launch a few satellites and get the whole planet. We have to have a ship there or a robot. We have to have something on site, and then around a few kilometers of that vessel, we can get some information. And for some things like chemical measurements, we cannot even do that. We need to have a sensor in the exact spot where we want to measure. So this is where robotics is the tool of choice. So instead of sending big expensive ships with crews on them, we can send robots that can go all these places. We can have many of them, collect data everywhere across the planet, and scale it up at a lower cost than if we would do it with big ships. So the challenges when building an underwater robot boil down to propulsion problems, navigation, and communication. So propulsion means you have to find a suitable way to propel the craft through the water, be it propellers or fins or sails or wave power, and an energy source to keep it going. Because the oceans are big. If you run out of energy, then you have to stop. Navigation is two things. The first problem of navigation is first knowing where you are. The second part of the problem is finding out how you get to the point where you want to go. So as I said, so on the surface with GPS, this problem is solved. We just switch on a GPS receiver, we know within seconds where we are. Once we go below the surface, GPS won't work anymore, so suddenly it becomes very, very difficult. And lastly, communication. If we have robots exploring the seas, they have to report back to us. We want to get the data they collect, so they need to be able to communicate with us. Again, on the surface, we can use satellite communication. Underneath the surface, we can transmit data for a few hundred meters, maybe a few kilometers, but not back to us where we are. So now there's a lot of solutions to all of these problems. So here's a few examples of the robots that have been developed in the last few years by various companies that solve some of these solutions in very clever ways. So at the very top, you can see autonomous surface vehicles, ASVs. So these are robots that can travel the oceans for months or even years by cleverly using wind power or wave power. So they do not rely on a battery or a fuel tank. They can just use the energy of the ocean to keep going. But they're limited to the surface. So it's already very useful. They can cover large areas. They can stay out there, monitor for many years, bring useful data, but only of the top part of the ocean. Now, to go under, there's two different types of technologies. One is remotely operated vehicles. So these are remote-controlled submarines, typically with a camera on it. You can remote control them. You can use them to do underwater inspections, underwater construction. So all of the offshore infrastructure is built with robots like this. All the maintenance is done like this, all the inspection tasks. One of the big limitations of these robots is that they rely on a cable, because we cannot get live video through the water itself over great distances with acoustics. It's just not fast enough. So typically these robots have a cable, which also often provides power to keep them running. And then lastly, we have the autonomous underwater vehicles, which are submarines that solve the communication problem by not relying on it. They're designed to be autonomous. So that means they get a mission uploaded beforehand, and then you launch them, and they go. And as they're on the road, you don't hear back from them. They have to figure it out by themselves. They do their mission, they follow different coordinates, follow trajectories, take measurements, and then hopefully at the end they return to you and you can get the data. And sometimes they don't. And this is actually scary if you think that a lot of these devices here that have been developed are very, very big and expensive machines. They can cost millions of pounds. And so if you have something go out for a day or two under the ice in Antarctica sometime, you do worry if it will come back to you or not, and sometimes it doesn't. So now in the recent years, there has been a push now to make this technology lower cost so that we can afford to have more of them and we don't have to be quite so afraid of losing them every now and then. And so that's one thing we have been doing. So this is our Vertex AUV that we've been developing at Hydromea, which is quite small. It's 70 centimeters long, weighs 7 kilos. And the idea here is to have a low-cost, easy-to-use, lightweight, simple, small system where we can afford to have many of them operating as a team so that we can cover larger areas with many, many robots that work together. And it can be used as an AUV, so it is designed to be autonomous. You can put a mission in it, it will go, it will start collecting data and then return. And we also now are working on making it an ROV as well by putting a camera on it. And we don't like to have this cable, so we were thinking of ways how can we do live video without needing the cable. So now if you remember the plot I showed you in the beginning, there is a very small window of visibility for blue light. And so we developed this optical modem called Luma, which uses blue light to transmit high-speed data. So we can get live video over distances of 50 to 100 meters transmitted with this optical technology, which is still not the perfect solution to everything, but it cuts the cable, it makes these vehicles far more agile. They can go into places where otherwise you would be worried that you might get tangled. And you just can do inspection tasks much easier and much faster. So now, what is the future of robotics in ocean exploration? So I think we need a lot more robots to cover the areas we want to explore. And we want these robots to interact with each other. And I think this is where communication technology is the key. Because right now we have a lot of new robots coming up, the surface vehicles, the underwater robots, the AUVs, but they usually operate by themselves. They go out, they go on a mission for a day, they come back, or maybe they roam the ocean, but they're one vehicle in a big open sea. Now, if we look at the capability of each of these vehicles, they all have their limitations. And it's very difficult to overcome these limitations in a single system. But now if we put all of these different parts together and we allow them to communicate with each other so that they can work together and collaborate, then we can tackle the big task of making this whole system work. So here in this graphic, so we could imagine we have these surface vehicles going over the ocean and they recharge by using the wind and the waves and they can go forever. And they stay at the top. And then we have these underwater vehicles which can explore the depths and take measurements down below, but they have limited energy, so they need to recharge. But they can come back to the surface vehicle, recharge, and then go back down. And while they're doing that, they can transmit all the data they've collected to the surface vehicle, which can then act as a relay to pass it on to a satellite network and pass it back to us on shore. And now all of these technologies are coming online now, even including better high-speed satellite networks that would cover the whole globe. And my prediction is that once we have all of these technologies work their way up, eventually we can put them all together and can have a system where we have all these robots collaborate. We have underwater vehicles go to subsea sensors, collect data, bring it back to the surface by just going up, doing inspection tasks, doing measurements, and we get so much more information which will allow us to manage the oceans more efficiently.